So we want to take the derivative of the function y is equal to 9 arctangent of x plus the square root of 1 plus x squared. You have to recall that the derivative of the arctangent function is 1 over x squared, and because our argument is just not a single x, we're going to have to use the chain rule and multiply by the derivative of this x plus the square root of 1 plus x squared. So let's go ahead and do that. We get y prime equals, and leave this 9 out here because it's a constant, and just multiply it through at the end. It's going to be 1 over 1 plus, in our case the argument is x plus the square root of 1 plus x squared, and that's all squared. But now the chain rule tells us we still need to differentiate this inner function and multiply it on the outside. So the derivative of x is 1, and the derivative of the square root of 1 plus x squared would be 1 half times 1 plus x squared to the negative 1 half. But we also can differentiate this 1 plus x squared even further, and the derivative of 1 plus x squared is 2x, and that gets multiplied. These 2's cancel out. That's a nice thing. So let's see what we have here after we clean it up, because we've done the calculus part of it. Now it's just algebraic manipulation to clean it up. So we have 1 over 1 plus x plus square root of 1 plus x squared times 1 plus, this ends up being x over the square root of 1 plus x squared. Oh, and I left my squared off of here. So, there's a few things that can happen here. We can go ahead and expand this, and then we can also rationalize this piece of the function of the derivative to get rid of this radical in the bottom. So we're going to go ahead and do that. So we get y prime equals 1 over 1 plus, when we square this, we're going to get x squared plus 2x times the square root of 1 plus x squared plus 1 plus x squared. And when we rationalize this, let me do it in another color. We can multiply this by so that's going to give us 1 plus x root 1 plus x squared over 1 plus x squared. We can clean this up a little further. We can combine like terms. We have like terms here and also here. So that's going to give us 2x squared plus 2x root 1 plus x squared plus 2. Now if we want to multiply with this second expression, we need to get a common denominator to combine the 1 and this x root 1 plus x squared over 1 plus x squared, and that's pretty easy because we have a 1 here. We just need to multiply by 1 plus x squared over 1 plus x squared, and now we have a common denominator. So when we add these together, we're going to end up with, if we put it in descending order with the highest power first, we'd have an x squared plus x root 1 plus x squared plus 1. This is all over 1 plus x squared. Now you notice you can factor 2 out of this denominator here, and we get 1 over 2 times x squared plus x root 1 plus x squared plus 1. And now that factor in this denominator looks just like the factor of the second numerator, and they can cancel out. So that leaves us with y prime equals 9 over 2 times 1 plus x squared.